Hi everyone, welcome to day 4 of derivatives. Today's learning target is I can apply the quotient rule to find derivatives. So already we've learned the definition of the derivative, power rule, product rule. Today we're learning about the quotient rule. So the quotient rule is as follows. If u and v are differentiable functions of x and v does not equal 0, then d u over v over dx is equal to v u prime minus u v prime over v squared. So I know that seems like a lot with the notation, so a little bit of an acronym to help you understand this. So this is what I have. F of x is equal to high over low. F prime of x, the derivative, is equal to low times d high, which is the derivative of the high, minus high times d low, which is the derivative of the low, all over low squared. So this is kind of how I read it. Low d high less high d low, all over low squared. So take a moment, try to process that, and we're going to apply that to our first problem. So example 1, find f prime of 2 when f is equal to x squared minus 1 over x squared plus 1. So I want to find first the derivative of it. So the first thing I'm going to do is I'm going to write low, and my low is going to be x squared plus 1. Because remember, this is the high, this is the low. And therefore, my high is going to be x squared minus 1. Now I'm going to find d low, which is the derivative of the low using the power rule, is 2x. Now d high is the derivative of high, which is also 2x. And now we're going to apply the low d high minus high d low over low squared. So f prime of x, the derivative, is equal to low, so that's x squared plus 1, times d high, which is 2x, minus high, which is x squared minus 1, times d low, which is 2x, all over low squared, which is x squared plus 1. Multiply all that out. I'm not going to multiply the denominator, and you'll see why in just a moment. So a lot of cancellation is going to be happening here, but I'm going to be left with f prime of x is equal to 4x over x squared plus 1 squared. Now remember, I'm not just looking for the derivative, I want the derivative of 2, so I have to substitute 2 in. So 4 times 2 all over 2 squared plus 1 squared. So 4 times 2 is 8. 2 squared is 4. 4 plus 1 is 5. 5 squared is 25. So there you have it. 8 over 25 is the derivative of f of 2. Let's look at example 2. If f of x is equal to 5x to the 5th minus 2x squared over 3x plus 2, find f prime of x, or the derivative. So this is low, this is high. So I'm going to write low is 3x plus 2. High is 5x to the 5th minus 2x squared. Now we want to find the derivative of that. So d low, the derivative of 3x plus 2 is just 3, the coefficient. And d high, 5 times 5 is 25. 5 minus 1 is 4. 2 times 2 is 4. 2 minus 1 is 1. Now I'm going to rewrite the formula, the quotient rule. Low d high minus high d low, all over low squared. So we're going to substitute. So f prime of x is equal to low 3x plus 2 times the derivative of the high, which is 25x to the 4th minus 4x squared, minus high, which is 5x to the 5th minus 2x squared times 3, all over the low, which is 3x plus 2 squared. I'm going to multiply all that out and then simplify, and I'm going to get 60x to the 5th plus 50x to the 4th minus 6x squared minus 8x all over 3x plus 2 squared. And then I'm going to factor out using GCF a 2x, 30x to the 4th plus 25x cubed minus 3x minus 4 all over 3x plus 2 squared. And I'm going to leave it like that. And there's my derivative. The next 3 questions are practice questions. Find the derivatives of each. So why don't you take a moment right now, use the quotient rule. Make sure you write out low D high, high D low, and pause the video to complete those questions. And here are the answers. So again, if it's helpful, write high over low, and then write them down. Find the derivative of 4x minus 1, which is 4. The derivative of 2x plus 3 is 2. And then apply the formula, the quotient rule. 4x minus 1 times 2 minus 2x plus 3 times 4 all over low squared. Again, you can kind of think of it as the diagonals as well. Multiply them and then subtract them. But make sure you divide it by the low squared. And I get negative 14 over 16x squared minus 8x plus 1. Again, apply the quotient rule to number 2. The derivative of x to the 4th plus 1 is 4x to the 3rd. The derivative of x to the 3rd minus 1 is 3x squared. Multiply and subtract divided by the low squared. And this got cut off, so let me just rewrite this. Plus 2x to the 4th plus 1. So y prime, or the derivative of y, is equal to negative x squared, x to the 6, excuse me, plus 4x cubed plus 3x squared over x to the 8th plus 2x to the 4th plus 1. And finally, for the last question, number 3, notice I have f of x is equal to negative 3x minus 6 over x plus 2. Now, I'm only going to focus in on this, the negative 6 over x plus 2. So my low is my x plus 2, my high is the 6. The derivative of x plus 2 is 1. The derivative of 6, which is a constant, is 0. So this can make it a lot easier because I'm going to be multiplying by 0. So because I'm multiplying by 0, the x plus 2 goes away. So I'm left with negative 6 over x squared plus 4x plus 4. Now I'm going to take this and put it back. Now notice here, guys, if this is negative 3x, to find the derivative of that is just the coefficient. So it's negative 3. So I apply it. When I have a minus and a negative, it turns to a plus. So f prime of x is equal to negative 3 plus 6 over x squared plus 4x plus 4. And that was the quotient rule. If you have any questions, please message me. Feel free to go back in the video and pause anytime. Have a great day. Thanks.